So like CPU and memory, networking and storage is a similar concept, where when it comes to a physical architecture, the operating system and its applications have 100% of dedicated access to the physical network card that exists on that host. But when it comes to a virtual infrastructure, we know that in almost every case, all of our virtual machines are going to need a virtual network card. And there's certainly no way that we would have on our ESXi hosts, say, for example, if I ran 50 virtual machines on a host, there's no way I'm going to have 50 network cards on a host. So in our case for networking, VMware has established the concept of a virtual switch. So like having a whole bunch of computers in a room, all attached to a physical switch with an uplink maybe to a closet somewhere in our data center. Okay. In the virtual world, we're going to have a virtual switch with virtual network cards attached with a virtual RJ45 Ethernet Cat6 cable to a virtual 10 gigabit or 100 gigabit switch, depending on the physical infrastructure. Now that's all well and good if I want my virtual machines that are all running on the same ESXi host to be able to communicate with one another. Heck, I don't need a physical port at all. But if I want those virtual machines to be able to communicate with virtual machines and other physical machines out there either on our LAN or on the wider internet or on our WAN or whatever it might be, then I have to provide physical networking to my virtual switch. So like a switch in any data center, like a edge switch, for example, I need to provide an uplink on that switch to, say, a core switch. Well, in my virtual world, every single virtual switch has at least one uplink, and it provides pass-through access to a physical port. That physical port on a physical ESXi host. Now, yes, I can create a virtual switch without a physical uplink, but that's hardly ever done. So when I build a virtual switch, it asks me, hey, what physical uplink port would you like to send traffic to, should that traffic be destined for some sort of resource outside of that ESXi host? So that is the basics of our virtual networking. We're going to dive into, in Module 5, exactly how those virtual switches are created and configured. Not only to support my virtual machines, but also to support ESXi's networking requirements themselves. So ESXi will mount this VMDK file to the virtual machine, and it's this VMDK file that is seen by the guest operating system as a disk, as a hard disk, an SSD, an NVMe device. And that's where you'll install your operating system, or that's where you'll put your data files for your applications, right? You can actually have multiple virtual hard disks attached to your virtual machines, okay? And the point really for all of this is that this VMDK file exists on a piece of shared storage. Okay, now that shared storage simply means is that I have some piece of storage that is accessible by multiple ESXi hosts. And by having this virtual machine disk file, along with all of the other files that make up a virtual machine, accessible by multiple ESXi hosts, it means that this virtual machine is now portable. It can run on any host that can see that shared storage. Now that shared storage can be accomplished and configured in a number of ways. We can establish it with fiber channel-based storage, or NFS-based storage, or iSCSI, or vSAN, hyperconverged storage. There's even another architecture that we call VMware's virtual volumes, which is very similar to vSAN, but where vSAN is utilizing internal storage, virtual volumes uses external storage. Okay. So we're going to create this external data store. Now this data store, we use this term data store simply to represent a place where I can have virtual machine files. And this is where my virtual disks will go. When I build this virtual disk as a specification for my virtual machine, if that virtual disk, I say, is 100 gigs in size, right? That means Windows will see a 100 gig C drive, for example, and that VMDK file itself will be 100 gigs in size. Now, there are some exceptions to this, and we're going to talk later on about thin provisioning and thick provisioning and different ways that we can lay those virtual machine files off on the data stores. But you get the picture, right? That's the basics of how we handle storage for virtual machines. Now, we've talked about CPU, memory, network, and disk, the 4 food groups of your server-based systems, right? But we now more and more are having a 5th food group, and we call that GPU. So if you have GPU hardware created by the companies like NVIDIA or AMD, or even Intel has some video cards that we can see in ESXi, we can take the GPUs that are on that hardware, those graphics processing units, and we can assign them to virtual machines. Okay. So this gives us a lot of different features. We can actually do virtual desktop infrastructures by utilizing GPUs for actual graphics work. We can do general purpose GPU compute, things like blockchain, really very high level math, brute force password hacking. Those sorts of things are also done really very, very well by GPUs. So general purpose GPUs can also be assigned as virtual devices to your virtual machines. So if we have the appropriate corresponding physical hardware, we can configure virtual machines with up to 4 virtual GPU devices. We support AMD and NVIDIA graphics cards for these purposes. Okay? We'll dive a little bit more into GPU virtualization when we talk about some of the capabilities that we have in virtual machines around things like vMotion. Okay? We'll talk more about that later. But for now, that does it for the basics of virtualization around the interaction of CPU, memory, network, and storage with your virtual machines and ESXi.